So hello everyone, this is Jay, your instructor for computer networks. The topic we are going to see is the link state routing. Routing has two types, the static routing and the dynamic routing. And dynamic routing is further divided into two types, which is interior gateway routing protocol and the exterior gateway routing protocol. And the interior gateway routing protocol is further divided into two types, which is the distance vector routing and the link state routing. In the previous lecture, we have discussed the distance vector routing protocol. In today's session, we are going to see the link state routing. So let us begin. In the link state routing, all the routers will exchange message with each other so that they can learn the entire network topology. After that, they will create the shortest path tree using the Dijkstra's algorithm. So in the network, each and every router will create their own shortest path tree. And to create the shortest path tree, they will use the Dijkstra's algorithm. So let's see how it works. As you can see on the screen, there is a network in which there are 5 routers, which are A, B, C, D and E. The distance between each routers can be seen near their edges. For example, the distance between A to B is 5, the distance between A to C is 2, A to D is 3, then C to B is 4, C to E is 4 and B to E is 3. Now to create the shortest path tree, each and every router will follow the Dijkstra's algorithm, and the flowchart that you can see on the screen is the flowchart for Dijkstra's algorithm. So each and every router will use the Dijkstra's algorithm and they will create the shortest path tree. Right now we are only interested for the device A. So right now we will create the shortest path tree for router A only. All the routers in the network are divided into two categories, the tentative list and permanent list. So in the Dijkstra's algorithm, in the first step, we will move the root node into the tentative list. Now what is the root node? The root node is the first node in the shortest path tree. So right now we want to find the shortest path tree with respect to router A. So the root node is the device A. So in the first step in Dijkstra's algorithm, we will move the root node into tentative list. The value in the bracket shows the distance from device A. So the distance from itself is 0, so A0 is written in the tentative list. After that, we will move every node from the tentative list to the permanent list. And which node will be moved? The node which is having the shortest distance. So right now we have only one node, so we will move one node to the permanent list. Now, when we move the shortest distance node to the permanent list, we will add its adjacent node to tentative list. So what are the adjacent of the router A? The adjacent of the router A are B, C and D. So we will move this adjacent of the recently moved node to the tentative list. So the first adjacent node D will be added to tentative list. Now you can see D3. So what is the meaning of the value in the bracket? The value in the bracket will always tell you the distance from the root node. So the distance from the root node is 3, so D3 is added to tentative list. The next adjacent node is B and we will add B to tentative list. Now what will be the value in the bracket? B5, because distance from A to B is 5, so B5 is added. And the last adjacent node, which is C, it will be added into tentative list. So the first step is completed. After that, the same procedure will be followed. Again, we will move the node from tentative list to permanent list. But which node will be moved? The node which is having the shortest distance. So let us write all the nodes as it is, and from the all nodes, the node C is having the shortest distance. So we will move the C2 into the permanent list. So after we move any node from the tentative list to permanent list, we will add its adjacent node to tentative list. So what are the adjacent of the C? Adjacent of the C are A, B and E. Now you have to remember that we will not add every adjacent node to tentative list. We will only move unprocessed nodes to tentative list. So which nodes are called as unprocessed nodes? Unprocessed nodes are those which are not present in the permanent list. So as you can see that C is having 3 nodes, A, B and E. We have just moved C from the tentative list to permanent list. So we will add B and E to tentative list. We will not add A to tentative list because A is processed neighbor and A is already there in the permanent list. So let's add adjacent node of C to the tentative list. So we will add its both adjacent node which are B and E, and the value will be 6, E6 and B6. Now why the value of these nodes are 6? Right now we are reaching the routers B and E via C. So the distance from C to B is 4 and distance from C to E is 4. But we are considering the distance from root node. So if you consider distance from root node, so A to C and C to E will be E6 and A to C and C to B will be B6, right? After again we will follow the same procedure. Now one more thing that you need to consider is that when you find the same node with different distances, we will only consider the node which is having the shortest distance. You can see that we have B5 and B6. So the node is same but the distance is different. So we will consider only B5 and we will eliminate B6. Now after that again we will move the node from the tentative list to permanent list. Which node we will move? The node which is having the shortest distance. So D3 is having shortest distance, so we will add the node D to the permanent list. Now after adding the node to permanent list, we will add their adjacent nodes to tentative list. But which adjacent nodes will be added? Unprocessed adjacent nodes. Now D is having any unprocessed adjacent nodes? No. D is having only one node which is A, and A is processed. A is already present in the permanent list, so we will not move the A again in the tentative list. Okay? After that we have two values B5 and E6 in tentative list, so we will move the shortest distance node from tentative list to permanent list. So which node will be added? B5 will be added. So we will move B5 from the tentative list to the permanent list. Now after moving node from tentative list to permanent list, you know that we will add unprocessed adjacent nodes. So B is having actually 3 nodes which are A, C and E. What are unprocessed nodes? Unprocessed nodes are nodes which are not present in the permanent list. So A and C are already present, so we will not add again those nodes into the tentative list. Only one unprocessed neighbor the router B has, which is E, so we will add E to the tentative list. So you can see that E8 is added. After that, we are having two values for E. You know that whenever we find the two values for the same node, we will consider the shortest distance. So after that, we will move the E6 to the permanent list from the tentative list, and as you can see that the task is complete, and we have to stop when there is no entries are left to move from tentative list to permanent list. So as you can see, all the entries in the permanent list shows the shortest path tree from the root node A, and the distance which you are having in the bracket are the shortest path distance. So from this shortest path distance, you can create the shortest path tree from the root node A. So let's create the shortest path tree. This is our shortest path tree, and from this shortest path tree, router A will generate its routing table. So this is how the Dijkstra's algorithm is used. Remember, we have find the shortest path tree with respect to root node A. In the network, all the routers will create their own shortest path tree, and after creating the shortest path tree using the Dijkstra's algorithm, they will prepare the routing table. So your task is to find the shortest path tree with respect to the remaining nodes. And this is it for the Dijkstra's algorithm as well as today's session. If you have any doubt, you can ask me in the comment section. Thank you so much.